Okay, in this video, what I'm going to show you guys is how to do two different ways on doing unit conversion. One is the dimensional analysis way that we showed you guys last year, and then as well as using the exponents. So as we go through each one of them, the big thing to know is how to come up with your different prefixes for all of these. The way you can remember them, except for the first one and the last one, you can remember, if you can remember, King Henry died unusually drinking chocolate milk. It gets you all of your units. So if I uncover this and show you guys, we have, and like I said, excluding mega and micro. So we have King Henry died unusually. This is our base unit. That's the reason why it's unusually drinking chocolate milk. And then you just have to remember micro and mega. What's nice about all of these is they all decrease by 1, except for, again, our top and bottom ones. If we look at our exponents on all of these. So mega is 10 to the 6th. So if I had a megameter, for every 1 megameter, it would be 10 to the positive 6 meters. So this is just telling you how many meters you would have, or how many of the base unit you would have. So then, like I said, once you go from mega to kilo, it's just a jump by 3 for the exponents, so we're at 10 to the 3rd. Then hecto is 10 to the 2nd, deca is 10 to the 1st. The base unit is 10 to the 0, which is actually 1. Like 10 to the 0th power equals 1. Then deci is to the negative 1st power, centi to the negative 2nd, milli to the negative 3rd, and micro to the negative 6th. Now, for all of their symbols, which we've talked about in class as well, mega is a capitalized M. That's the big difference between mega and milli, is one's capitalized, one's not. Kilo is K, hecto is H, deca is either D-A or D. I've seen them both. As well as deca can also be spelled with a K instead of a C. It's the British version of it. Base unit wouldn't have a prefix symbol for it. Deci is a lowercase d, centi is a lowercase c. Like I said before, milli is a lowercase m, and micro is the Greek letter nu, which is a U with this funny tail on the front of it. Okay, so I'm going to show you two different ways to convert these units. So the first way is going through and doing the dimensional analysis that you guys learned last year. So what we can do is we can start off with, if we're doing 100 centimeters to megameters, as we would just start off with question mark mm equals 100 centimeters over 1. So we want to go from centimeters to meters, and then meters to megameters. So what we can do is, when we look back at this, so for centimeters, for every 1 meter, it'll be 1 times 10 to the negative 2nd centimeters. Or we could just leave it as, I should make that too a little bigger, 10 to the negative 2nd, because 1 times anything is the same as anything. So we can almost ignore that. Now when we look at mega, for every 1 meter, it's going to be 10 to the 6th, or 1 times 10 to the 6th, but we can shortcut it. So now all we have to do is just do our math here. So when we look across the top, we have 100 times by 1 times by 10 to the 6th, all over 10 to the negative 2nd. Now when you're looking at this, you can use some of the tricks that you learned in class. So 100 is 10 to the 2nd. So now all we have is 1 times by 10 to the 2 plus 6, because I'm just adding these two exponents together. But then we're also subtracting this away. So it's also then a minus 2 is what we can say. So this is actually 1 times 10 to the 6th. It's kind of a little bit of a longer way, but this is usually the easier way to go when your metric units aren't powers of 10. So, or we could do it using the exponents. So you start off with whatever unit we're starting in. So we have 100 centimeters. So centimeters is a 2, because remember, you take with whatever you start with, and subtract from wherever you end, and that is the number, or the exponent, not the number. So we're starting at 2, so negative 2 minus whatever mega is 6, so that is to the negative 8. So we have 100 times by 10 to the negative 8. We know 100, or you should know that 100 is 10 to the second. So we have actually 10 to the second times 10 to the negative 8th. So then that goes to 10 to the negative 6th. So just like before, we have 1 times 10 to the negative 6th. Oh, and I forgot my units. So that's how you can go through and do those. If you're doing units that aren't so nice and neat, so let's use a reference of time. So time isn't this base 10, this very nice system here. So our exponents don't really work. So let's say we want to know how many seconds are in 75 days. So if we have 75 days, 2 seconds. We actually cannot use this method here. We actually have to go to this method. So to start off with, we want to find seconds. So question mark seconds equals. We're starting off with 75 days. So we're going to put 75 days on top and put it over 1. Remember, this is how you always start it off with. You start off with question mark, what you're looking for, equals whatever you're starting with over 1. So now the next part of this, since we're trying to go from days to seconds, so first off, whatever you have on top of this fraction, only the unit, not the number, that label or unit goes down below. So we have day down below. Now whenever we reference anything, so we're trying to convert in between these, so our next jump, I would go to hours, because we want to try and go into smaller units of time. So for every 1 day, we have 24 hours. So then our days cancel. Now if we continue, whatever you have on top and just the label gets moved down below. So we have hours. And then the next smallest unit for hours would be minutes, unless you know how many seconds are in an hour. But for this, so for every 1 hour, we have 60 seconds. So our hours cancel, but we're still left in minutes, so we have to go even smaller yet. So we have, oops, jumped the gun. We have minutes down below, because whatever's on top gets brought down below. We're going to change this now to seconds, because we know how many seconds. We know there are 60 seconds in 1 minute. And now we just have to do our math. So now when we look across the top, we're going to multiply everything together. When we look at the bottom, we can multiply everything together. What's nice about this bottom is it's 1 times 1 times 1 times 1, so we can just leave it alone. So I'm just going to show my work down below. So we have 75 times by 24 times by 60 times by 60, because that's all of our numbers there. And that equals, okay, and what that equals, so I've already punched it into my calculator here. So we have 648,000,000, and then that's seconds. And there's our answer.